Hey guys, we're just going to go through three problems here. We're going to be talking about the Pythagorean Theorem, and I'm pretty sure you guys have seen it before. You can see it listed here, I'll highlight it, but here's the Pythagorean Theorem. C squared is equal to a squared plus b squared. So we're going to use that right now, okay? There is a converse that says that if the legs and the hypotenuse fulfill this equation, then the triangle you're dealing with is right. So as you can see, I broke down the original triangle, said that C was actually equal to X because that's the hypotenuse. Remember, this is the hypotenuse, and this is a leg, and this is a leg, okay? So I just labeled either one of the legs. A is 2, B is 7. I substituted. I then did the squares. I combined, and I took the square root. And we can't simplify the square root of 53 anymore, as it says. Type an exact answer. So our answer would be the square root of 53. The next one, we have a walkway forms one diagonal of a square playground. The walkway is 24 meters long. How long is the side of the playground? Well, there's a couple pieces of clues here, right? A square playground. That means that each leg or each side of the playground has to be a certain distance. We don't know what that is, so we're going to let D be that distance. And so I said, let D be the distance from the walkway to the vertex. In other words, from this pink point all the way down to this vertex down here, okay? And the same thing from this pink point to this vertex here. So we've now made a right triangle, which is great because now we can apply the Pythagorean theorem. And that's exactly what we did. In step 1, we applied the Pythagorean theorem. In step 2, we combined things on the left-hand side of the equation. So d squared plus d squared is 2d squares. We then just squared 24, came out to be 576, divided both sides by 2, took the square root of both sides, and then I factored the radicand. Remember, the radicand is the number underneath the radical, and I factored it into perfect squares, 36, 4, and 2. So the square root of 36 is 6, the square root of 4 is 2, so 6 times 2 is 12, and the square root of 2 stays the square root of 2. We can't do anything else with it at all because we don't have another pair of 2's. And you'll see this will be very important for us in a little bit. So we've actually just sort of proved something that we're going to be doing later. Okay, last problem is 9.1.41, and it says find the value of x. So you can see that we have this nice triangle here presented to us. I'll highlight it just so we can see that we're talking about it. I redrew it right away because, you know, when in doubt, draw it out. Okay? And luckily we have right triangles, so then we can apply the Pythagorean theorem. So what I did was, since I realized that this was a right angle, then this is also a right angle. So I broke the two triangles apart. And you can see that I labeled A as the altitude here, and then I applied the Pythagorean theorem. 4 squared plus A squared equals the quantity 4 root 5 squared. So I'm just following the same pattern. A squared plus B squared equals C squared. I then just did the computations out very quickly. Squaring 4 root 5 just means that I'm squaring 4, which is 16, and I'm squaring the square root of 5, which is 5, with technically the absolute value of 5, but regardless. So after that, what we did was we simply did the product out, simplified, and found our A. Now, how did we find array? We just took the square root of both sides, right? So we just took the square root of both sides. Okay. So I'm hoping the computation isn't that bad. So now that we know what the altitude is, we can now find what x is. So I simply set it up again, set it up with the Pythagorean Theorem. The hypotenuse squared plus the leg squared, equals the sum of the two legs squared. So that's x squared equals 8 squared plus 20 squared. That's 8 squared is 64, 20 squared is 400. I combined the two, then I took the square root, and then I broke them up into perfect squares. I'm looking for perfect squares. So what I did was I took 464 and I divided it by, 4. Well, that's a perfect square. 9, that's a perfect square. 16, that's a perfect square. And it happened to go in 29 times. So the square root of 16 is 4. And we can't do anything with the square root of 29. So our final answer for the last problem is that right down there. Okay, and that's how we have to type it in. I hope this was sufficient enough. Let me know in the live stream. We'll talk about it, but I'm trying to keep these videos within 5 minutes. All right, thanks, guys. Have a good day. Bye.